Hello friend, in this video I will discuss some most important results of limits. So first we will discuss three important results of trigonometric function, that means sin, tan and cos. So in case of tan, if you apply here DL Hospital rule, okay. So first we put the limit numerator and denominator. This will obtain indeterminate form. So we can use here uh, DL Hospital rule, okay. So in DL Hospital rule we have to difference numerator and denominator separately. So applying DL Hospital rule in both the cases, applying DL Hospital rule in both the function. So we can simply write differentiation of tan x is sec square x or sec square and differentiation of theta is 1, limit theta tending to 0. So on taking limit sec square 0 is what? If cos square is 0, cos square 0 is 0, then sec square 0 is also 1. Since cos 0 is 1, then sec 0 is also 1. So the limit of this function is 0. This is the first method to solve this question, and second one is series method, okay. If you apply here tan x, series of tan x, so it is x minus x cube by 3 plus 2x 5 upon 15 minus and so on upon x. X or theta we can write here. If you write here theta, it's okay. Theta cube and theta to the power 5 upon theta. If you want to take common numerator, this will equal to theta tending to 0, theta 1 minus theta square by 2 plus 2 theta to the power by 4, theta to the power 4 upon 15 and so on upon theta. This term will cancel out. On taking limit we will have 1 minus 0 square by 2 plus 2 into 0 to the power by 4 upon 15 minus and so on. On solving this we will have 1. That means limit theta tending to 0 tan theta upon theta equal to 1. In both the methods we can solve easily. In same, if you apply DL Hospital rule in sin theta, okay, so it will equal to what? Limit theta tending to 0, differentiation sin is cos theta and differentiation of theta is 1. So if you take limit here, then cos 0 equal to 1. So the limit of sin theta by theta at theta equal to 0 is 1. Now second method, if you apply here sin x series, okay, sin x series, so sin theta is what? Theta minus theta to the power 2 upon 2 plus theta to the power 4 upon 4 and so on. So we can write, we will take common numerator, okay. Limit theta tending to 0, if you take theta as common, then this will become what? Theta minus theta upon factorial 2 plus theta cube upon factorial 4 and so on upon theta. The term theta will cancel out here. On taking limit we will have 0. That means 1 minus 0 upon factorial 2 plus 0 cube upon factorial 4 and so on. On solving this we will have 1, okay. So finally what we will obtain? Limit theta tending to 0 sin theta upon theta equal to 1. Similarly we can prove the third result, that means the cos limit theta tending to 0 1 minus cos theta upon theta equal to 0 we have to prove, okay. On applying DL Hospital rule here, so we can simply differentiate numerator and denominator separately. So differentiation of numerator is what? Differentiation of numerator is 1 is 0 and differentiation of cos is minus sign. Then this sign will become plus sign, sin theta upon theta, okay. On taking limit we simply put we again here apply DL Hospital rule, okay, because no, this term will become 1, okay. On taking limit we will have 0. And the second method we can apply Cosx series, that means limit theta tending to 0, the series of Cosx is what? This is 1 minus theta cube upon 3 plus theta to the power 5 upon 5. This will goes on infinitely, okay, upon theta. If you solve this, multiplying minus inside, okay, 1 minus 1 plus theta cube upon 3 minus theta to the power 5 upon 5 and so on upon theta. So this term will cancel out. Now finally we have limit theta tending to 0. If we take theta as a common, then we will have theta square upon factorial 3 minus theta to the power 4 upon factorial 5 plus and so on. If you take limit here, then we'll finally what we have 0, because all the terms will 0 after taking limit. So finally we have limit theta tending to 0 1 minus cos theta upon theta equal to 0. So this is all about in this video. Thanks for watching. Thank you so much.